Here, we present XMP-Font, a few-shot Chinese font generation method. Generating a new font library is a very labor-intensive and time-consuming job for glyph-rich scripts. Few-shot font generation is thus required, as it requires only a few glyph references without fine-tuning during test. Existing methods follow the style-content disentanglement paradigm and expect novel fonts to be produced by combining the style codes of the reference glyphs and the content representations of the source domains. However, these few-shot font generation methods either fail to capture content-independent style representations, or employ localized component-wise style representations, which is insufficient to model many Chinese font styles that involve hyper-component features such as inter-component spacing and connected stroke. Typically, a font style involves unique morphological structures of a character at multiple scales. For example, stroke-level styles involve stroke-level features such as weight, hollowness and serifness. Component-level styles implies how strokes are oriented and joined to form a component. Character-level styles engage character-level features including the component layout, inter-component spacing and connected stroke. First, let's look at a set of results. A complete Chinese font includes tens of thousands of Chinese characters, hundreds of different Chinese character components and completely different arrangement and combination methods. Because Chinese character fonts have strict requirements on the number, position and frame structure of strokes, general image translation models do not have a deep enough understanding of Chinese characters. The frame structure of fonts is also an important type of style information. For some more difficult tasks, such as calligraphy font repair or when there are only a very small number of reference characters, the success rate of previous font generation methods is low. Using the same 4 characters with different fonts as reference, XMP-Font is able to transfer an ancient Chinese poem to look very similar to the reference font. The training of XMP-Font is divided into 2 stages. 1. Pre-training stage. Pre-train a BERT-based cross-modal, text image and stroke order information, feature extraction model, and use the reconstruction loss and stroke prediction loss to ensure that the extracted font features can be extracted without losing information. Fully understand the relationship between strokes. In order to enable the model to understand the relationship between the picture and the corresponding Chinese character stroke order, we train on a large dataset with the following tasks. 1. Predict the stroke order that is covered. 2. Image reconstruction. When the pre-training phase is completed, Chinese characters in any font can be perfectly reconstructed, and the overlaid stroke order prediction accuracy rate can reach more than 80%. 2. Font generation stage. The features of the source domain word and the reference word are extracted respectively through the pre-trained feature extractor, and the decoupling and recombination is performed to finally generate the source domain word with the same font as the reference glyph. In this phase, the encoder of the pre-trained part is fixed, and only the decoupled network and decoder are trained. We also propose a novel stroke loss based on a pre-trained LSTM-based stroke order predictor to enforce the correct stroke order of the generated glyph instead of the existence of stroke labels only, which proves to benefit the structure preservation and faithful generation of stroke order-related style features, e.g., connected stroke. Due to the style of the font domain is defined by appearance features of multiple scales, measuring the visual quality with a unified metric is a challenging problem. In addition to ground truth-based metrics, we also use evaluation metrics that does not require paired ground truths. Other than the objective metrics, we conduct a user study for quantifying the subjective quality. We observe that XMP-Font outperforms other methods in both seen and unseen font generation scenario for most evaluation metrics. In the unseen domain scenario, Ours exceeds others in all metrics by large margin. Especially, our method achieves a remarkably 28% higher success rate on unseen font domains over the second best. As shown in this figure, the blue and red boxes highlight the bad cases. The advantage of our XMP font is highlighted with more successful transfer of styles of all scales. XMP-Font preserves both the detailed local style and fine-grained global styles and generates the plausible and recognizable images consistently. Such a noticeable gap in visual quality explains the large performance leap of XMP-Font in the user study. We use unseen fonts as reference fonts and find their nearest neighbors in the training set and compare them with the generated results. This verifies that our method does not overfit the training data. The fact that a single glyph can produce good results with our method is an advantage of our XMP font. Indeed, it is difficult for a single glyph that is too simple to fully represent the whole font library. It can be observed that using more reference characters makes our results more robust. Finally, let's look at the generation effect of 3 different sets of generated fonts on the 3,000 most commonly used Chinese characters. Thank you.